Welcome, everyone, and thank you for attending today's webinar, Key Success Factors for Analytics in Mining and Metals Companies. My name is Tom Trappell, and I'll be your moderator. Today, our featured speaker is Martin Provencher, Industry Principal for Mining, Metals, and Materials at OSIsoft. Today's webinar will take roughly 45 minutes, followed by 10 to 15 minutes of Q&A. But before we get started, I'd like to mention a few housekeeping notes. This webinar is being recorded, and we will be providing the recording and slides after the webinar. You can expect an email with the content following the conclusion of this event. We'll also be conducting a poll during the hour to better understand your experience with analytics in the metals and mining industry. Your participation is highly appreciated. And finally, if you have a question for Martin, please submit your question via the Q&A option on the WebEx digital event platform. If we're not able to get to everyone's question today, we will certainly follow up with response afterward. And with that, I'd now like to hand it off to Martin to get started with today's presentation. Martin, thank you for joining us.
Thank you, Tom. So thanks, everyone, for joining. Let's start with, well, first, analytics. I mean, the word analytics is now used in many different ways. It can even be seen as a buzzword that everyone wants to use. If we look at the definition of Gartner on analytics, actually an abstract from the definition, advanced analytics is the autonomous or semi-autonomous examination of data using sophisticated techniques and tools to discover deeper insights, make predictions, or generate recommendations. So the important aspect here is that if you want to do analytics, you need to have access to the data. And that's what we will cover a little bit here, that presentation. So first, we'll look at some facts and statistics as an introduction, and then we'll look at where should we be doing analytics. Now we're talking more and more about the edge and the cloud, so we'll cover that a little bit, and how it is used in the industry. And also, we'll cover some most advanced techniques. We'll talk about a little bit about artificial intelligence. So based on an OSIsoft survey that was performed in 2019 on mining metals companies, 40% of industrial companies have started their digital transformation and are seeing value out of it. So that's pretty good. Out of those 40%, 47% of them see that digital transformation will have an impact on their asset health. So that's the highest ranking that we've seen. And then it will have an impact on their costs and, of course, on reliability. So that's a major thing in the mining and metals industry. And also, we've seen that 25% of those companies have not started, so they're lagging behind. So that's something that they should start thinking about, definitely. Now, according to an IDC market forecast that was done in 2019, the worldwide spending on Internet of Things was forecasted to reach $745 billion in 2019. That is huge. That is an increase of about 15% year over year. And according to the latest IDC study from January 2020 on artificial intelligence in mining, there's about $2 billion that will be spent on artificial intelligence by 2023 only in the mining industry. So it has begun. And AI is mainly looked at from an equipment automation perspective. We're talking about mainly autonomous vehicles, but there's a great focus that is also being spent on digital twins in areas of virtual reality and augmented reality. So the good news is that, like I said, it has started. So another study that we have performed with Mining Magazine and Mining Intelligence, actually a study that was performed for OSIsoft, again in 2019, says that 24% of companies are using industrial or Internet of Things, so IoT sensors with analytics. So that's pretty good. And 53% have plans of using it or are actually making some use of it, but are not considering themselves being advanced. So that means that most people are starting to do some analytics, and that, again, is pretty good. Now, let's let's see why companies are actually investing in industrial Internet of Things and are looking at analytics. Well, mainly because they're losing money. They want to improve their processes. For example, unplanned downtime costs can represent up to 5% of their total annual production. So when we think about mining or metals companies, 5% of the total annual production represents a lot of money. And the good news is that 80% of that money or that spent can be avoided. So if of course, if we do some analysis on historical and on real-time operational data. But in order to do that, in order to analyze that data, you need to capture that operational data using a proper operational data infrastructure. Now, before getting into the details, let's have a look at where should we be doing analytics actually. We're talking more and more about the edge. We have more and more IIoT devices, industrial Internet of Things devices that are available that can actually perform some analytics. Those will mainly be used for remote assets, for example, assets that are remotely located and that there's nobody in there or almost nobody. And on the other side, we'll look at the cloud also to do some analytics. And now approximately 70% of the people are using the cloud mainly for testing, for backup, or for storage. But actually, the cloud can be used for data sharing, for advanced analytics, and to get the big picture with more data. So the objective is actually to expand the scope of the data. So we'll look at the edge so that we can perform some pervasive data collection, to look at more data sources, to do analytics on the edge. And we'll look at the cloud to do, like I said, remote monitoring, analytics that can take into consideration multiple plants or even multiple enterprises. For example, suppliers. You might want to do analytics to combine the data that you have in your mine or in your plant with the data coming from your suppliers. So the cloud is a very good use for that. And based on a Gartner study, around 10% of enterprise data is created and processed outside of traditional data centers. So that means that only 10% of the data is analyzed on the edge or on the cloud now. And that figure will change significantly. So by 2025, Gartner predicts that this figure will reach 75%. So it's going to be more and more used in the industry. Now, the idea here is to make sure that we're doing the analytics at the right place at the right moment. For example, if we're talking about a self-driven car or an autonomous vehicle, analytics must be done at the right moment. If we're talking about emergency brake or remaining useful life, those are two different analyses that can be done. Of course, if you're talking about an emergency brake, you don't want the data of all the surroundings to be captured in the vehicle, sent over to the cloud, analyzed in the cloud, and then sent back to the car because there's an emergency situation. There might be delays because of communication issues or something like that. So you want that analysis to be done on the edge. So that's the best example we can provide is analytics on this case must be done on the edge. And on the other hand, you might want to calculate the remaining useful life of your vehicle, which is not urgent, but you want to know about that. So you might want to share also that information to your supplier. You might want to do analytics based on suppliers' performances and things like that. So that can be done on the cloud. So two good examples of where we should be putting analytics at the right place, like I said. Now, how companies will benefit from analytics on operational data? Well, before doing analytics, like I said, you need to collect and contextualize the data. The best example I can provide with that is if you want to implement predictive maintenance using analytics. So we're talking about predictive maintenance 4.0, for example, which is becoming more and more popular in the industry. The thing is that you have to take into consideration the context of the data. For example, if you have a stoppage, you need to know what kind of stoppage this represents. If this is an emergency button that the operator has pressed, this is not a downtime. So your analytics solution should not consider it to be a downtime because it will make wrong correlations. So, and this is the main reason why 60% of digital initiatives fail is because of the fact that they capture the data, but they do not contextualize it. So if you have data that is not contextualized, analytics won't succeed. And this is why, like I said, 60% of those initiatives fail because 53% of the time that is actually spent by data scientists is on data preparation. So as a result, you're not using all the data for your decision, and only 1% of that data can be used. So that's a major aspect to take into consideration. And that's why you need the proper tools to help integrate real-time operational data that you're capturing through your IIoT devices, for example, or through your sensors or any other devices like that. And then you need to capture also the context of that data and then integrate it using the proper tools to your business analytics solution. And the best example we have about that is actually Cemex, which is a cement company. They have approximately 70 sites around the world. They were capturing all the information from their 70 sites. It took them 740 hours to do some analytics on that data. And now that they're using the proper integration tools, they're still collecting that information from those 70 sites. They're contextualizing it and they're integrating it with their business analytics solution in only 1 hour. So that's a significant achievement that Cemex has done, and that's a very good example. Now, of course, all operational data must be taken into consideration. So we're talking about real time, but a study from Deloitte in the mining industry says that to obtain optimal analytics, you must take into consideration different time horizons. So real-time data must be taken into consideration, that's for sure, but also historical data, what happened in the past, that's important. And also future data, what will happen? That's also information that you might want to capture. Of course, analytics will provide you that information, but you need to be able to store that data as future data. And the value of using all that data can represent an increase in productivity of about 10 to 20% based on that study from Deloitte. So very significant achievement can be done there. Now, the good news is that once you have a proper operational data infrastructure in place that can collect from your IIoT devices, from sensors, from your different assets, collects the data, it allows you to store and contextualize it with the digital representation of your asset and all the management of the different events that are happening during the life cycle of the asset. Then you can integrate easily with advanced business analytics on the cloud or on any other platforms. So that this means in order to perform successful analytics, you need to have that kind of infrastructure that allows you to have access to real-time operational data, historical data, and future data. So Tom, I will now turn it back to you for our polling question.
Well, thank you, Martin. Folks, at this time, we'd like to conduct a quick poll. We'd like to know, what is your business looking to achieve with advanced analytics? Is it maintenance or asset reliability, increased productivity, reduced cost, better worker safety, improved data visibility, or all of the above? Or if there's another advantage that you're looking to achieve, please feel free to submit that open response via the Q&A option on the WebEx platform. Martin, while we're waiting for responses to come in, with the companies that you've worked with in the past, where do you see the most advantage with trying to achieve advanced analytics?
Well, thanks, Tom. I think that's a very good question. And of course, I don't want to influence people responding, but for me, it's clear that, I mean, the mining industry and the metals industry it's an industry that is asset intensive. So there are huge costs associated with the maintenance or asset reliability aspect of it. So this is for sure an area, like I talked a little bit before about predictive maintenance 4.0. This is definitely an area where you can save a lot of money, and of course improve your asset reliability. So that's something that is significant. Of course, in terms of productivity increase, I mean, most companies are actually trying to do more tonnage with the same assets. So this is another area where there are significant areas of possibilities using analytics and take advantage of real-time operational data.
Martin, I'm curious, with maintenance and asset reliability, is there a correlation with that and better worker safety?
Yes, Tom, definitely. Actually, we have a customer, a mining customer that actually was looking at improving its asset reliability for their haul trucks. And actually, the customer is Syncrude in Canada. They have presented, so the presentation is available. And basically, they were able to save something like $20 million a year in terms of asset costs, in terms of maintenance costs on their haul trucks because of engine failures that were happening quite often. Now using the data and doing analytics with the data, they can save that money, but they have also been able to reduce by 82% their incidents in terms of dumping. So they had lots of dumping incidents, dumping that were performed too fast or at wrong speed. So they started using analytics and they started providing that information to their operators, to their truck operators. And the operators, once they know what's happening, once they know the risks, they will for sure take into consideration that. And they actually, Syncrude has actually been able to reduce by 82% their incidents, which is a significant improvement also in terms of safety.
Excellent. Thank you, Martin. All right, folks, at this time, we're going to close the poll and I'll announce the results. And Martin, the majority of our audience today chose all of the above. So with advanced analytics, they're looking to achieve like all 5 responses that we offered them today. So folks, thanks again for your participation. Martin, back to you.
Thanks, Tom. And actually, I'm happy to see that the result is is like that because that's what I would have hoped. What we see so far is a lot of companies are actually investing into or using data for mainly for maintenance or asset reliability, like I said. Some companies have started looking at increased productivity, but again, safety is an important aspect. Data visibility is another important aspect. So I think that if we take into consideration that all of the above can be taken, can be improved, that's a great thing because this is true. Analytics can save money, can increase reliability, can improve safety, etc. So that's a very good thing. Thank you very much. Thanks everyone for attending.
And some of the open responses we had one individual who mentioned that they're looking to have a big push toward asset reliability and accurate data reporting. So I can see where that comes in too.
Definitely. Very good. Thanks for responding, everybody. Let's move on now with some customer examples. Actually, I've taken just a couple of customer examples. Those are all available on our osisoft.com website. You can see the whole customer presentation, about 30 to 45-minute presentation. But I'm just taking some highlights of some of those here in the mining and metals industry. This is a very good example with ArcelorMittal that implemented an integrated operations center. Basically, they're collecting data from all their assets at the mine site, and they're doing analysis at their center, which is about 1,500 kilometers, 1,000 kilometers, something like that. It's quite far. So basically, they're collecting the data, bringing that into their center, and then they're doing analysis. And in that case, they're collecting the truck's data to perform road analysis. So that gives them insights about road conditions. So that's a quite interesting story. Of course, they're doing much more than that. I mean, within their integrated operations center. I mean, the improvements that they've achieved, they've increased the daily tonnage by 6%, which is significant. They've increased their truck productivity by 7%, again, which is significant. 300% reduction in the slowdowns at the concentrator because of low feed. Again, another significant impact. So lots of great impacts for ArcelorMittal, but definitely this is a very good example of capturing the data at the mine site and analyzing it with more data at another site. So a very good example. On the other side, I mean, if you would like to implement autonomous haulage operations, for example, again, like I said earlier, if you're trying to implement analysis on the emergency brake system, it will definitely have to be implemented on the edge, so on the truck itself. Again, that's another example to take into consideration. Another very good example here is with Barrick, the Cortez mine in Nevada. They used actually IIoT devices, those small white cylinders that you see on the top picture. Those are actually IIoT devices that collect about 40 vibration, temperature, etc. I mean, information about their asset in real time, and that sends it into their real-time operational data infrastructure. So that's a great example of implementing predictive maintenance 4.0 using real-time operational data. So as a result, I mean, within only 2 months, they avoided many downtimes and saved a major failure on a scrubber. So that's a very good example of a successful predictive maintenance 4.0 implementation that was done only in about 2 months. Another good example in the metal industry here is with Alcoa. Actually, Alcoa is one of the largest primary aluminum producer in the world. They have operations in something like 10 countries. Each smelter consists of a large number of pots, between 300 and 700 pots, and each of them needs to monitor multiple variables for their product process efficiency and productivity. So they basically use their real-time operational data infrastructure to collect and contextualize all their operational data, and now they can perform advanced analytics to help them take the best actions rapidly to ensure maximum productivity on each pot in all of their plants. So that's a very good example of a successful implementation of analytics. Again, those stories are all available on our website, so you're more than welcome to visit our website and see all of those stories. Next step is to talk about machine learning and artificial intelligence. Of course, this is coming. As I said, a study from, again, Mining Magazine, Mining Intelligence, and Aspermont Research that was done for OSIsoft last year on 115 companies, mainly responded by executives and senior directors, says that 80% of the respondents think that AI will change the future of mining. So that's pretty interesting. And the latest study from IDC that I referred to before in January 2020 says that artificial intelligence in mining will mainly be used. I mean, there are use cases for all the supply chain, from the exploration, safety, sustainability, asset operations, mining operations, etc. So there are great use cases of using artificial intelligence in the industry. Of course, before getting there, it's a step-by-step approach. So in order to do this, well, you need to have both subject matter experts, your guys, your people within your mine, your plant, that have the expertise, work with data scientists, and they must have tools to visualize and investigate on operational data. So that's a critical success factor for them to succeed. And one of the great examples we have of implementation of successful implementation of artificial in the industry is with Cemex. Actually, Cemex has the objective. Cemex is one of the largest cement producer in the world. They have the objective of implementing autonomous manufacturing by 2022 in their plants. So that's quite soon. They worked with AI, artificial intelligence specialists, and data scientists. So within a couple of months, they actually succeeded with a strong operator acceptance. So they've involved their operators in there. And the result was significant in terms of increased quality, increased productivity, reduced costs. The important aspect here is that the operator was not removed. We're talking about autonomous operations, but it's the same as for the operation of a kiln. In their case, this is a kiln operation. So, I mean, this is from a safety perspective, this is a very critical asset. So they are keeping the operator there. They worked with the operator to implement this. And it's the same as, I mean, would you take a plane without a pilot, even though there is an autopilot in the plane? I mean, this is the same thing. So when you're talking about safety, an operator should remain there in most cases. Now, how did they achieve that? Well, basically by taking a step-by-step approach. Of course, CEMEX has implemented previously their real-time operational data infrastructure. They've implemented maintenance aspects, process improvements, et cetera, et cetera. They've integrated with their ERP, and now they are at the stage where they are looking into AI. So first step in their AI project is that they looked at predictive approach. So they looked at predictive analytics. So were they able to forecast the prediction of the kiln operation in real time? So once they were comfortable with the forecast that they were getting, they started looking at prescriptive recommendations. So prescriptive analytics. So the AI model was recommending the set points to the operator, and the operator was looking at it and making sure it made sense. And then once the operator was comfortable with those set points after a couple of trial and error, but again, the errors were not implemented because the operator was seeing the error, so it was fixing it and working with the data scientists and the AI specialists. But then they fixed the AI model, and then they were able to implement the autonomous autopilot operation on their kilns operation. So now the AI model submits the set points to the control system directly, and the operator supervises the operation. So that's a very good example of a success story in artificial intelligence. So in conclusion, I mean, there are lots of spending in IIoT and analytics, as you can see, in AI also, that is starting. We're talking about billions of dollars in the industry. Lots of value to be generated in many areas, such as maintenance, production, etc. Again, the study from Deloitte says that if you're using the data properly, at least 10% of improvement will be reached, and we've seen much more in the industry. But analytics, again, should be done at the right moment. Data preparation is critical to the success, and it must be done before you start involving data scientists and talking about artificial intelligence. And that's why once you have the proper real-time operational data infrastructure that collects the data from all your different sources, that stores and enhances that data with its context, not just the data. Again, the context is important. Then you can integrate with advanced analytical tools, and we're talking about machine learning, artificial intelligence, pattern recognition tools, etc. So, and once you do all of that, you will succeed in your analytics survey. And of course, at OSI Soft, we strongly believe that people with data can transform their world. Thank you very much, everybody.
Thank you, Martin. Folks, at this time, we'll be taking questions from the audience. Once again, please use the Q&A option to the right of your WebEx interface, and we'll answer your questions as they arrive. If you've happened to change your view to full screen, the Q&A option may now be located at the bottom. Let's see what questions that come in. Martin, when you talked about improving asset reliability, does this mean it's possible to implement real-time predictive maintenance?
Yes, actually, Tom, once you have your proper real-time operational data infrastructure in place, the idea is to start building the asset structure of your assets in the PI system. And most companies do have reliability engineers or maintenance planners, and those people actually are performing lots of reliability-centered maintenance analysis, RCM analysis, when an asset fails. So they know the conditions that leads to a failure. So once they know those conditions, after they have done those analysis previously, well, if they have the proper data infrastructure in place and they have built their asset structure in that data infrastructure, of course, they can start implementing those conditions into their digital asset structure. So that's what the PI system allows you to do. So you can implement all your conditions, known conditions. And that's the same, I mean, we're talking about maintenance here, but that will be the same thing for process. Your process engineers, they know the conditions that lead to an improved process efficiency or to a failure in your process, or not a failure in the process, but a reduction in terms of efficiency. So once you know those conditions, if you have the proper data infrastructure in place, you can definitely start implementing condition-based monitoring on maintenance, on maintenance or process. But also, as you know, condition-based monitoring can also start to become predictive in terms of maintenance or process, because if you start being able to predict that there will be a failure, you are talking about predictive maintenance in terms of maintenance.
Thank you, Martin. Okay, our next question. What kind of digital tools are available that could help improve our operational and production efficiency?
Well, what kind of digital? As I said, the first thing that you have to take into consideration is having the right operational data infrastructure. That's critical, because you need to capture that data and you need to capture the context of that data. And then once you have that, again, build your asset structure. So that's, I mean, we can do all of this with the PI system, that's for sure. That's what I'm talking about with most customers. Some customers already have their PI system, but not all of them have realized the value that they can get out of implementing all of that within that same infrastructure. So again, the PI system is probably the best tool I would recommend. Of course, once you have your operational data infrastructure in place, once you have your digital asset representation in place, you can also start working with different analytics platform. But again, before getting there, I would strongly suggest you to start looking at capturing the data, capturing the context of that data, implementing what your people, what your process engineers, what your reliability engineers, what your environmental specialists, no matter in what area, I mean, your people, they already know what's causing your issues. So if they know that, and if they can implement it in your asset structure, in your digital asset structure, then you will succeed definitely. And then after that, you can start looking at the advanced analytical tools.
Thanks, Martin. Our next question, this audience member wants to know specifically, like, what is the typical role for OSIsoft and the PI system in delivering advanced analytics solutions to their clients?
OSIsoft actually delivers one platform, the real-time operational data infrastructure called the PI system. So that's basically what we're doing. Well, basically, it's not basic, because that's like I said, that's probably the most important aspect of capturing that data and context that goes with that data. In terms of analytics, you can do a lot of analytics within the PI system, within your digital asset structure, like I said. But of course, if you're talking about artificial intelligence, if you're talking about the advanced predictive analytics or prescriptive analytics platforms, there are great tools on the market that you can integrate with the PI system. And OSIsoft has a lot of partners that does that. I mean, does advanced analytics or advanced artificial intelligence, machine learning, etc. So there are a lot of tools that are available.
Excellent. And this, I think, this next question, I think, follows up into that. So you might need to reiterate, but this other individual wants to know, does the OSIsoft PI system have a complete toolkit to enable predicting and also forecast conditions based on data, or are there additional tools that are required or that you recommend?
Actually, the PI system does not do predictive analytics itself, but again, you have to be careful about that, because, like I said, once you start doing condition-based maintenance or condition-based process monitoring, you start, I mean, if you look at any maintenance documentation, you will see that condition-based and predictive maintenance, for example, are overlapping. So, I mean, the condition aspect here can all be implemented within the PI system. Once you want to go further, if you want to implement predictive analytics, I mean, we have great, I cannot provide a specific name. There are great tools in the market. I mean, what I would strongly recommend is to look at OSIsoft partners. I mean, the partners that are working with the PI system, because again, like I said, once you have your operational data infrastructure in place, you need to make sure that your platform that you're looking at in terms of analytics will work with the PI system. And we have lots of different partners that can do that. Again, it all depends on what is it that you want to achieve specifically. In terms of maintenance, I just presented one of them that does that, actually called PetaSense. In terms of artificial intelligence, I presented another example with another partner called Petuum. So we have different partners, we have different providers or integrators that have the expertise of implementing those tools. So again, it always depends on what is it that you want to implement exactly. But first, before getting into that journey, again, I would strongly recommend that you start doing what your people already know. There's a lot of hidden value in your people's brain. So that's what I would strongly recommend.
Thanks, Martin. Our next question, are there use cases for capturing IoT data into the PI system for geotechnical data, tailings, dam stability, or underground gases?
I mean, sometimes those can be done in specialized tools that are specially designed for that. When we're talking about, for example, you talked about geotechnical data. I mean, there are tools that are really specialized on capturing or analyzing that data. Of course, when we're talking about the PI system, we're mainly talking about the real-time, the operational data. If you want, for example, in terms of geotechnical, if you want to capture the data of your vehicles or of your assets that are collecting soil samples or things like that, that is something that can be done. But from a geographical perspective, I mean, there are great geotechnical tools that will do that job very easily. And of course, once you have that information, you can definitely integrate it into your PI system for advanced or for analytics in terms of process. For example, you might want to take into consideration the quality of the ore that's coming into your process. And then depending on the quality of the ore, you might want to adjust your process based on that. So again, integration and those systems will become a data source for your real-time operational data infrastructure. So those will mainly be used as data sources for your central data infrastructure.
Excellent. Thank you, Martin. Our next question, what do you recommend to a management team to help them establish a clear story or business case for this type of analytics transformation?
Well, typically what we do with our customers is we propose a kind of a workshop, a 2 or 3 day workshop, where we sit with management people so that they understand kind of the value that they can get out of using digital technologies or using data. And then we sit with those people that have the knowledge in their head, with those process engineers, those maintenance engineers, those environment specialists, etc., safety, etc. So we sit with all those people within a couple of days, and we build kind of a heat map where we identify the initiatives that will generate most value and the initiatives that will be the easiest to implement. And those are the ones that will be prioritized. And typically in those workshops, we will also work with your people in your plant, in your mine, and they will be the ones that will be building one use case during the workshop. And then after that, they know exactly how this is performed. Of course, before doing that workshop, we strongly suggest the companies to have the proper training, to have the proper installation being performed, proper training, and then after that, it can be done quite easily. In some cases, we have companies that have done that in only a matter of 2 or 3 months they have implemented their PI system, they have got the training, they have done this workshop, and they have got significant savings in terms of costs or in terms of productivity improvements. And then, of course, if you're struggling with the resources within your organization, we have lots of partners, integration partners that can help you achieve that. Those are people that are trained on the PI system, that have done it elsewhere. So we have a lot of partners that can also support. OSIsoft does not provide professional services, but we do provide those kind of workshops where we help those customers improve in terms of PI usage or efficiency.
Well, excellent. Thank you, Martin. All right, let's just see if there's any additional questions here. Okay, folks, if there are no further questions, I'd like to thank everyone for attending today's webinar. If you do happen to have any additional questions or responses for Martin or myself, please feel free to reach out to us from one of the follow-up emails sent out after the webinar today. Once again, thank you for attending, and we hope you have a wonderful rest of your day. And Martin, once again, thank you for presenting today.
Thank you very much, and thanks everyone for attending.
Take care, everyone.